Now we understand that the expression log of x to the base a is equals to b is also equal to a raised to b is equals x. Now we'll try to answer some questions or problems on changing logarithm expressions to exponential expressions. So letter A, log of m to the base 1.2 is equals to 3. Let's change this to a exponential equation. Okay. Write our base 1.2 raised to 3 is equals to m. Letter B, log of 24 to the base a is equals to 24. Write our base, which is a, raised to 4 is equals to 24. Letter C, logarithm of 64 to the base 4 is equals to 3. Write our base 4 raised to 3 is equals to 64. Now let's try finding the exact value of logarithmic expressions. So for example number 1, logarithm of 16 to the base 2. Okay, so first we will write this on the exponential form. We will think about what is 2 raised to what number will yield 16. Okay. Now we have to simplify 16 so that we can cancel the base of 2 so that we can have the value of y. Okay, so what number of 2 raised to what number is equals to 16? So we will think 2 raised to y is equals to 2. Okay. 2 times 2 is equals to 8 by 4 times 2 is equals to 8 times 2 is equals to 16. So 1, 2, 3, 4. 2 raised to 4. Now we can cancel our base. We will yield the answer y is equals to 4. Example number 2. We will try to find the exact value of logarithm of 1 over 27 to the base b. So first we will try to think what is 3 raised to what number will yield 1 over 27. So now we will have to think of a number that will cancel out this base 3. So let's try 3 raised to y is equals to 1 over 3. Okay, so try 3 times 3 equals to 9 times 3 equals to 27. So 1, 2, 3 raised to 3 is equals to 27. So we can simplify this fraction as a negative exponent because we know that 1 over a number is equal to the negative reciprocal of that fraction. So 3 raised to y is equals to 3 raised to negative 3. Now we can cancel out our base 3. The answer will be y is equals to negative 3. Let's try to solve this example. Okay. Log of 4x minus 7 to the base 3 is equals to 2. First, let's convert this to the exponential form. So base 3 raised to 2 is equals to 4x minus 7. So let's simplify this. 9 is equals to 4x minus 7. Okay, transpose negative 7 on the left side. 9 plus 7 is equals to 4x. So let's find x. 9 plus 7 is equals to 16 equals to 4x. So divide both sides by 4. Our x is equals to 4. We know that the product rule of logarithm explains that the logarithm of m times n to the base b is also equal to the logarithm of m to the base b plus logarithm of n to the base b. Now we'll try to solve an example. So we will try to solve this and find for the value of x. So we will set this first term as our m, this second term as our n. So by using the product rule of logarithm, we will have logarithm base 2 of our m x plus 2 times 3 is equals to the logarithm of 27 to base 2. We simplify this one on the brackets. So logarithm base 2 3x plus 6 is equals to log base 2 27. So now we drop the logarithms. We write 3x plus 6 is equals to 27. So transpose 6 to the right side. 3x equals to 27 minus 6. We will write 3x is equals to 21. Solving for x, we will have x is equals to 7. This is the answer. Now we go to the quotient rule of logarithm. So based on this rule, we know that a logarithm of a fraction on a base b is equals to the difference of those two numbers. Okay, so let's try to solve this expression. So first we will write our m. Let's write m for our first term, and then for our next term, since this is a subtraction, we can use the quotient rule of logarithm. So same as here, m and n. Okay, so we write this as logarithm base 5 of m x plus 2 over x is equals to logarithm base 5 of 2x minus 1 over 3x minus 12. Now we simplify this. We drop our logarithms and we cross multiply these two equations. So let's write x plus 2 times 3x minus 12 is equals to 2x minus 1 times x. Let's simplify this. Use the FOIL method. Okay, 3x squared minus 12x plus 6x minus 24 is equals to 2x squared minus x. 3x squared minus 2x squared minus 12x plus 6x plus x minus 24 is equals to 0. Three x minus 2x squared is x squared. Negative 12x plus 6x, negative 6x plus x is equals to negative 5x minus 24 is equals to 0. Now we will try to factor this equation by the lessons we learned on factoring. So, what two numbers, if we have the sum of those two numbers, will yield to negative 5x and a product of negative 24. So, let's try negative 8 and positive 3 and positive 8 and negative 3. So, the sum for these two numbers will be negative 8 plus plus 3 is equals to negative 5, and 8 plus negative 3 is equals to positive 5. So we will use these two numbers to get our factors. So the factor for this equation will be x negative 8 and x plus 3 equals to 0. So the solution for this expression is equals to x equals to 8 and x is equals to negative 3. This is the answer. Next one, we have the power rule of logarithms. So on this rule, we can use to simplify the logarithm of a power by rewriting it as a product of the exponent times the logarithm of the base. So let's try these examples. So let's expand this. So this exponent 5, write it first. We bring down the exponent and then we write our logarithmic expression x. Next one, we simplify this. Logarithm base 3, 5 squared. We bring down the exponent to logarithm base 3 of 5. Same with this one. Let's simplify this. X raised to 1/2. Let's write a 1/2 logarithm base a of x. For the next one, we have the power rule of logarithm. So this rule says that we can simplify the logarithm of a power by rewriting it as the product of the exponent times the logarithm of the base. So let's try this example. We write the exponent 5 and then the logarithm of the base root of x. Next example, to simplify this, 5 squared. So we write our exponent 2 multiplied to the logarithm of the base. Next one, we write this as x raised to 1/2. Then we write our exponent multiplied to the logarithm of the base.